Okay. So in this lecture, we are going to study about acid transaction. What is acid transaction? Okay, acid transaction is not something which will end up you inside jail. Okay, acid transaction is a way how you can write inside a database. So basically, this database provides some abstraction which have some properties. Okay, and those properties should follow acid transaction for the for best reliability. Okay, so here A is atomicity, C is consistency, D is durability, and I is isolation. Now we will see each of them one by one. Okay. So first one is atomicity. So in atomicity, all writes should succeed or none should succeed. So for example, let's say this is me. Okay, and this is this is a marketplace. Okay, this is a marketplace. So I have sent 10 rupees to the marketplace. So from my balance, let's say there was $100 or 100 rupees, minus 10 should happen. And then this is the bank account of this marketplace. Here, let's say there was 1,000 rupees or $1,000, and there plus 10 should happen. It shouldn't happen that minus 10 happened in my account, but plus 10 didn't happen in his account. Either both should pass or both should fail. Okay. So this is what we call atomicity. The second thing is consistency. So in this, all fields occurs gracefully and there should be no variance if something is broken. So let's say you are inserting something in database and due to something it failed. It shouldn't happen that there is stale values or there is corrupted values inside the database. So that is what we mean by consistency. So the third one is isolation. So all transactions are executed uh, independent of each other. So it shouldn't happen like, let's say there is a counter, okay, counter, okay, and A is trying to increase it by plus one and B is also trying to increase it by plus one at the same time. So it should be plus two, right? But let's say both try to increment it by plus one. So what happened that it only increased by plus one because there was only one signal. So it shouldn't happen. This one should have its own. Uh, this one should happen on its own, and this one should happen on its own. They should not collide with each other. Or let's say, for an example, the count. Okay, A tried to increase it by plus one, and at the same time, B tried to increase it by plus one. Sorry, B tried to increase it by minus one, and only B happened. Okay, A and B happened at the same time, so A was rejected, and the count is plus one. It shouldn't happen. The count should be zero. Okay, plus one and minus one, it should be zero. So this is what atomicity means. So basically, what I mean is that there should not be any race condition. Last but not least, the durability. Okay, the committed data don't get lost. Data should be on the disk. It shouldn't happen that you have committed the data. Okay, so there are two things. One is writing the data. Okay, one is writing the data. So that time it is in memory. Okay, it's in memory. And then committing the data. Okay, when we commit, it should go inside disk. It shouldn't happen that once the power is down or something bad happens, the data is lost. So that is durability. Okay. So there is as such no rule that all the acid transaction should happen. Okay, but it is good to have all these features inside a database. So mostly the atomicity is managed by write ahead logs. So let's say I'm paying someone money. So from my account 10 is deducted and from his account 10 is added. And when we commit it, the value, the changes inside the DB are stored in write ahead log. So even if the DB crashes or like even if the power went off, when it comes up, it can recover everything from write ahead log. Okay. And the isolation is hard and it's a bit slow. So we will understand about all the things we do for maintaining this acid transaction in the upcoming lecture. Thank you.